right, so if we just take a look at the first one, when you're graphing by intercepts, it's actually pretty easy because you just have to make a dot at each intercept and then connect them. So x-intercept at -4, just make sure you're on the x-axis, you put a dot at -4, and a y-intercept at -4. Connect the two dots. That's it. That's it. Just that easy. So try it with number 2 here. You have an x-intercept at 1 and a y at -4. I am. Okay, before we continue, double check that your graph looks like my graph for the second one. Can someone tell me the slope of this line? Do you remember how to find slope? 4 over 1, right, or just 4. I'm going up 4 to the right 1, up 4 to the right 1. It's positive because I'm going up from left to right. Whereas if you look back at number 1, you would know right away that the slope must be negative because it's going down. And what would the slope be of number 1? -1, correct, because I'm going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. All right, now when you hit one like number 3, it's a little bit different because this, they just give me this equation, I have to graph it. You have options. One option is to rewrite this into slope-intercept form, y equals mx plus b, or you can graph this by intercepts. Do you remember doing that? So one of my intercepts is actually going to be really easy. When the line crosses the x or y axis, isn't the other variable just 0? So in other words, when it crosses the x-axis, isn't the value of y 0 at that point? Right? So if I look at this one, it crossed the x-axis at 1, but y was 0. When I look at this one, y is -4, but x is 0. So I can find those two intercepts by plugging in 0 for each one. So if I plug in 0 for x, doesn't that whole term just go away? Right? If x is 0, that term's just gone. Now I just have this equation, and if I solve it, that gives me the y-intercept. So if 4y equals 8, y must be 2. So I just put a dot at +2. Now, we don't get quite so lucky when I plug in 0 for y. I get 3x equals 8. I can solve, but it's just not as nice of a number. If 3x equals 8, then x must be 8/3, right? When I just divide both sides by 3. So I'd get 8/3. Where is 8/3 on here? I would convert to a mixed number, right? 8/3. 2 and 2/3. So that's my x-intercept, is at 2 and 2/3. And then I can connect those two. So that's one option. It's useful when both of these numbers divide into that number evenly. That's when I would recommend doing that because it's so fast and easy, right? So on number 4, for example, we'll go ahead and do it there because it's going to be so easy. This I had to, I'm guesstimating a little bit because I don't know exactly where 2 and 2/3 is. I'm just kind of eyeballing it. So if you were going to rewrite this into y equals mx plus b form, I just want to get the y by itself. So I'd minus the 3x over. So let me just rewrite it here. Usually this is what you do. You minus the 3x over 4y, -3x, and then plus 8. And then I would do what? Divide everybody by 4. So I get -3/4 x plus 2. Now, if you remember how to graph when it's in slope-intercept form, do you remember where do you start? Yes, I start at 2 on the y-axis, my y-intercept. Well, lo and behold, of course, I already knew that there was a dot there, but then I can just follow my slope, negative 3/4. It should create the exact same line, right? So let's just see. If I go down 3 to the right 4, well, la-dee-da. Look at us go. So, like I said before, you could graph it either way. It's going to be a bit more accurate if you rewrite it into slope-intercept form, though, given that that's a whole number. So, number 4, you could graph it by intercepts, or you can rewrite it into y equals mx plus b. Both of them are just as easy as each other, because to get that into y equals mx plus b, just minus that x, right? So you're there very quickly. Y equals negative x plus 1. So where would I start? Positive 1, and then my slope is, so I go, my slope is negative 1, where would I go? Yes, it's a very common mistake to go down and to the left. You never want to go to the left. You always go to the right. If it's negative, that just means down instead of up. But you should always be moving to the right. So there is that one. You probably already know how to graph 5 and 6 because they're already in slope-intercept form. So I'll give you a moment to graph them if you haven't already. And if you forgot, I will remind you. If it's in slope-intercept form, you always start here on the y-axis. That's your y-intercept. And then you follow your slope. So if it's negative 3/5, that just means go down 3 to the right 5. I'm always going to the right. Connect my dots. Did you get a graph like mine?
Yes. I agree.
Good. And then 6 should be pretty straightforward too. Did you start at 4 on the y-axis?
Yes.
And then where do you go?
Down 2 over 1.
Over which way?
Right.
To the right. Always to the right. That's it. You got it so far? Okay, let's check out the back. Oh, come on. These are too easy. Well, at least let's look at number 9. That one's got a hint of something more difficult. What are you going to do with number 9?
Multiply everything by 2.
Clear the fractions, yeah. Let's multiply everything by 2, and then it turns into not that hard of a problem. Wow, these are way too easy. I should have checked them before I hit print. Too easy. When you cleared the fractions, did you get the same equation that I did? And then did you start at positive 1 and go down 4 to the right 1? Oh, good. So did you get the same line as that? Super easy? Okay, on that same grid, so the same grid for number 9, okay, we're just going to reuse the grid space. Do me a favor and graph this, x equals 3. Don't say anything out loud, just graph it. Graph the line x equals 3 on that same grid. Is my graph going to be horizontal or vertical?
Vertical.
Correct. If you forget, first of all, I'm hoping that as soon as you only see one variable, if you only see x or you only see y and you don't see them both, then it's a Hoy Vux problem. Since I have x equals, I'm not dealing with that, I'm dealing with this one, and it should be a vertical line where x is equal to 3. So I hope you all graphed this. Did you? A vertical line at 3. Yeah? Okay. Let's do 10 and then I'll give you a harder one on 10 too. So, what do I do first with this thing? What do you want to do? Well, I kind of have y by itself. I just got to get rid of that negative. Oh. Oh, yeah. So in 10, if I just want to make this whole thing positive, what could I do? Divide everybody by a negative. So I get y equals, and I'm going to put the x term here where it belongs, negative x plus 2. Easy enough? And then I would just start at 2, and then down 1 over 1, down 1 over 1, down 1 over 1. Okay, so let me give you another one, which is very easy to do if you recognize something about it. Try and graph on this same grid for me. Let's graph this. Go ahead and graph that one for me. On that same grid. Everybody got an answer? Graph to graph? So, let me ask you this question. How many of you rewrote this into y equals mx plus b? Okay. You absolutely can. Did anybody not manipulate the equation at all and you just graphed it just by looking at this? You did? How? Correct. This is point slope form if you recognize it. Remember that was y minus y1 equals m times x minus x1? So if you happen to notice that it's in that form, you can extract the information out of it without having to do any math. You just take the info out. So you know 2/3 is going to be the slope. And then remember that it's the equation is minus. So how would I get that? What must x1 have been to turn that into a plus 3? It must have been a negative 3. So 1 point on my line is negative 3, comma, negative 2. And you know the slope. The slope is always just right in front of that. So what I can do is just start at that point and follow the slope. So that's an option. So -3, -2, and then follow my slope of 2/3, up 2 over 3, up 2 over 3. So there is one way to graph that line in point slope form. So try and extract the information from this one. We'll graph it on the same one. How about y minus 2 equals -1/2 x plus 4, like that. So see if you can graph that without turning it into y equals mx plus b. Actually, can I change one little thing? Oh no, go ahead, you do it. I'll do another one. Okay, what point is on this line? -4, comma 2. If that's what you said, you got it. -4, 2, and then the slope is, yeah, -1/2. So I can start at that point, -4, 2, and then follow the slope, -1/2. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. So here is the graph of that line. Wow, pretty cool. Let's just do 12 together real quick. And then I'll give you one or two tougher ones to try. What are you going to do this time? Actually, here's a great example of a time that you can't graph by intercepts. You could try. If I plugged in 0 for y, that means the y would go away. 0 equals 2x. What must x be? 0. So it's crossing the x-axis at 0. But then if I try the same thing for plug in 0 for x, I just get y equals 0. So it's crossing the y-axis at 0. You can't, the two dots are both on the origin. How are you going to connect that to make a line? You can't. So if it passes through the origin, then I run into a snag. I don't have two dots. I only have one dot. You can't connect one dot to make a line. You have to connect two dots to make a line. So I can't graph this one by intercepts, but I can graph it if I just minus the 2x to the other side. I know I start at the origin, and then where do I go? Down 2 to the right 1. That's it. Okay, on this same graph, try to graph for me the following. I'll give you a hint, or should I not? Okay, I won't. I'll let you try it. And then when I say this, some of you will be like, oh, that would have been so much easier than what I did. So there's an easy way and a hard way for this one. I wonder which one you'll do. I hope so. In this instance, I agree with you. Did you distribute the negative 4/5?
No.
I wouldn't have either. You don't have to. Isn't this still in point slope form?
Correct.
It is. It is. It's just misleading because there's no number over here with the y. But there is. What number? It's just a 0.
There you go, Phil.
Mm-hmm. So the point that's on this line would be what? Careful. Negative 3 comma 0, right? Because there's your x, there's your y. And then your slope is just negative 4/5. Could you have gotten this same line by distributing the negative 4/5? Yeah, but then you have this messy fraction and everything's kind of a mess. You can do it, but this is so much easier. Look, negative 3, 0, and then I just follow the slope, negative 4/5. I can't do a negative 4/5 because I'd be off my graph, but I only need one, so tra-la-la, there we go. Did you get the same graph I did?
Yes.
Oh, good.
I
All right.
Passed.
Any problems with graphing that you can think of?